everyone. Welcome to the scripting workshop for the Showcase Your Culture Hackathon, hosted by LensList and MetaSpark. My name is Beth. I'm an XR developer and I'm the Associate Innovation Director at Signal Theory in Kansas City. Working at Signal Theory, I've had the opportunity to create AR effects for brands like Sonic Drive-In and John Deere, and collaborate on effects for National Geographic. I was commissioned by Meta to create an effect for the Reels Remix booth alongside Coachella, and I'm a Meta certified Spark AR creator and working on countless effects for my own creative exploration, and I've had the opportunity to work with some really great digital activist organizations like Big Tent Creative, Voice, and Babes Helping Babes. We're going to be making a version of Gem Smash World. It's an immersive AR effect, which was featured in the first publication of the LensList Creators Case Study blog. For this workshop, I have provided a template which has a lot of the things already set up in the project. And I'm going to assume that you're familiar with working with incorporating 3D objects into projects and working with animations in the patch editor, the plane tracker. I actually started with the real scale world object template, the starter template with the MetaSpark software. It already has the script for the world object placement, the tracker instructions, and the manipulation. And we have this 3D spinning globe. It's from Sketchfab. And I've added these little diamonds with the shader. We'll talk a little bit about that. Let's take a look at the patch editor and see what we have going on in here. So we have a lot of patches already in the project, the starter template, so you don't have to try to build this as we go. This is the scene render pass section. I'm just using this so I can have the anti-aliasing shader, and I've got some render order set up for this. Is just the background. The plane tracker goes on top of that. This is my bouncing object, the bunny, goes on top of the plane tracker and it's connected to the device. These items marked in red, I kind of like to call them variables. I'm used to working in script, and you create a variable to store a bit of data in one spot, so when you change it, it changes everywhere. And then I have those connected to these senders. So we have some variables from script already in here. This is from the placement script. Whenever the tracker is ready, this fade content is activated. So I am using that here to see if the tracker's ready, and then if you tap on the screen, that is connected to a Boolean, so I know that my game has started, and then I can trigger the timer. So I have the timer duration set to 45 seconds. That's going to receiver. So I reset the runtime and check for if the runtime is less than 45 seconds. So that pulses the timer, which is in the heads up display block, and also goes to this sender. So if the game goes past the set time of 45 seconds, plus I have an animation delay of 1 second, that's when the globe comes up, scales up, so that's added together and signal that the game is over. Also got a lot of stuff here, which is just the world spinning around and scaling. So here I'm just rotating the globe on a 360 loop for 10 seconds. bunny is bouncing on a loop. Every half a second it bounces. This was more important on the face tracking effect because I had it timed. At every jump, you would be in the right position. You just had to go use your nose to steer the bunny left or right. So right now we're only controlling our trigger object just by moving the camera around because we're dealing in a world AR experience. Animations here for the targets. I have those going left, right, just to make it a little more challenging. It seemed like if they were just coming in the same spot, you can just stay where you are and you don't really have to move to hit each target. And these little random patches here. So every time the loop for the bouncing bunny completes, it triggers this randomized pulse, and it changes the duration animation for the targets, so they speed up. Here we have the shader for the little diamond shaped gems. I have a refraction patch, and this is a Dolly generated image. This refraction patch is from a tutorial on Medium by Theobald Everard. So if you go into it, I've got the link here if you want to read more about it. It's pretty good. Otherwise, we've got the patch here available for you to use. Just plug in any texture. You can use the camera texture into this refraction patch, and I have added in a texture transform here, which just spins the texture around in a circle. So I've got a loop animation. It spins it 180 degrees, rotating for 6 seconds, just so they look a little bit different. About the mechanics of the game, and when you're using this starter template, you can switch out your experience here. You'll just want to keep in mind that I have these targets. They're just in a null to keep this is an empty null, which this is what the target is, and then whatever shape you want to hit. So I'm just going to drag that into the patch editor so it can take me to where this stuff is. This is all the collision patches, which I have, since I have this connected to render past, it's stretching. This is the bouncing object connected to a global transform into the object. So I need to do that for each of my hit targets. I've got 10 diamonds. So to do the 3D collision in patches, you have your target object, and each colliding object. And those are connected to a distance patch. So each one of these distant patches has the bunny and the hit objects. So if you're going to use this for a project, keep these things, and then you can just switch out the diamonds. And then here I have a group of patches. If we dive into that, here I've got another variable first. This is the distance threshold. I just wanted to keep that in one place in case I use it anywhere else, which I don't happen to be right now. So the distance, if you are less than 0.25 from your hit object and your bunny object, then you just trigger a boolean. So I have one for each individual target, and then I also connected them with all of these OR patches. So if I hit this one or this one or this one or this one, then I have an all trigger, which means I can trigger something to happen anytime I hit any one of the targets. But if I want it to be specific, like I have an emitter, or maybe something happens to an individual object that I don't want to happen to all the objects, then I would use these individual hit targets, which I'm not right now. But for the Gem Smash world, it came in handy because each one I had kind of explode, and I used vertex displacement for that, which was a bit too much to go into now. And to learn about that, I was on Noland Kalila's Patreon. They have a full tutorial on there how to do vertex displacement and with a glass shader combined. So I highly recommend doing that. It's still available on their Patreon. The name is Always Coding Something. You may know them. For this project, I am not really doing anything to each individual gem. I just have this emitter with the bouncing bunny here that explodes every time you hit any one of the objects. I have the birth rate increasing to 111, otherwise each one sits at 0. And this is where that text comes up, so anytime I hit an object, it'll change to true. And I got another sender here if you want to use that anywhere else. Since this guy isn't moving right now, we can test this by just unplugging this and manually moving the bunny just so we can see what happens. You can see there's a little emitter goes off and it changes to true. You can fudge around with the numbers here for the distance. Sometimes you want to make it a little bit bigger just so it's not like really hard to hit, because it's a little bit harder on this as a real world object game rather than an in-camera face tracker game. It's a little bit harder to hit the objects, so I kind of made it a little bit bigger. Then maybe it's not a super precise thing, so you don't have to be right on it. You just have to do some testing. You can put like a test plane or anything on there just to see and stop this animation, or disconnect them entirely just to test out how far you need to get to each object in order to make that trigger pulse. We are going to use the scripting API for the persistence module, and we're going to add some haptic feedback. I do have a script already here for the emitter particles. This was originally created by Josh Beckwith. It just fades out the particles at the end of their lifespan and also animates the size. I'm going to add the persistence module to track the high score. And if you want to follow along, I've included the script as an external resource in the workshop assets, or it's already included in the finished project. So we're going to import a script, and I'll find it here. Rename it something a little more legible. So if you view the console, we have an error for an unhandled promise rejection, which is because we do not have our two script signals set up yet, which this script is reliant on. So let's see what we have in the script. First of all, if you don't have this extension, it's very handy. It helps you finish writing your syntax. It gives you clues on how to write code for Spark. So available in the Metaspark scripting resources, Metaspark extension for Visual Studio Code. You can download it there. This script I originally sourced from a series of tutorials on Metaspark on the documentation. There's a whole scripting course by Viv Gallinari, and if you haven't seen that, I highly recommend watching all of these videos. And this one in particular talks about the persistence module, and that is where I started the script from. And I remixed it a bit to show the high score from the beginning of the project. It just needed a little bit of revising for that. So here are the patch outputs that we need. We have a max hit and game over, and we have some inputs for the high score, show high score, and a time up message. So first of all, let's do our inputs. If we go back to Spark in our from script, we need a number, and that was the current score. We need another number for the high score and a time up message, which is text. And you may want to copy and paste from the script to make sure you get those spelled right. We also need a Boolean for the show high score, because if you haven't played the game yet, I don't want to show the score, so I want to be able to turn that on and off. And we have some two script signals that we need to add, two pulses, one called max hit and another called game over. So these are coming from our patches to the script, and this is coming from the script to our patches. This I'm feeding into that heads up display for the scoreboard. So if we go back to the patch editor and click on the heads up display block in our scene, and I need to get to this guy, which you see has gotten bigger. I'm going to make some room here. So I now have current score, high score, time up message, show high score. The current score here, that's always fun. There we go. So let's connect the current score to the heads up display score. The high score is next. Let me just get the other one, the show high score, before it bounces me back and forth. Okay, high score, show high scores down here. The time up message is here. That tells me the game's over, and just gives you a little message to tell you how you're doing in the game. I'll just leave that here. So, okay, when the game, we want to make sure our game is on, so I'm going to add another receiver for game time, so we know we're currently playing the game. And I need a receiver, which I have already from the hit sender. So if I scored, if the game's playing and I scored, which you shouldn't be able to score when the game's not playing because it scales down, but just in case, I mean, it's not totally gone, it's just there. I don't know, I don't want to trigger any weird pulses, any ghost scoring when the games shouldn't be playing. So I'm going to attach that to a if then else, and I want it to be a Boolean. So if the game's playing, click on my script, the max hit, I want to pulse to my script that we have made a score. I also want to tell my script if the game is over, and we can do that from our patches. Add the game over pulse. So let's see now what we have going on in the console, I have an error that says exception and host function key high score is not whitelisted. So in Visual Studio Code, we have added the persistence module. These are our scene objects, which are patch outputs. I've got a variable for score, high score, updated text, input screen, and here's where this error is coming from. The persistence user scope get high score. We have to enable that in our project capabilities. So if you go to properties, capabilities, you can add high score here. So make sure your script is saved, and when I restart here, the errors are gone, and I have a diagnostics log message here that tells me there is no high score saved. This is great. Let's go back to the patch editor and remove the bouncing object from the plane tracker temporarily again and see what's happening. So we're getting some scores, and the console has some more messages telling me every time I hit the score and what the score is. You see it's not 1 point, which is also great because here are my variables. This is a const, which means it's a constant, and I have these as a let, which means they are interchangeable. They change as the game goes along. And we're waiting for the user scope high score. So if we have a high score, it gives me a message that what the high score is. High score dot value. I'm setting the high score to that value and saying, pulsing the Boolean that yes, we do have a score. Otherwise, it says no high score saved, and it's null if there isn't one. So this set Boolean feeds into the heads-up display and tells me there's my message. And it also says, the Boolean says to show what the high score is, if there is one. So if I restart, now I see here we have a high score of 384. Okay, very cool. Back in our score script, we can look at the next thing. We're making sure that we catch an error. If there is an error, it'll tell us in the diagnostics log. So this is a function to score the points. I did have different levels of scoring for my Gem Smash World game, but for here we're only going to have one function for one score, and I am adding 24. So every time you hit a target, it adds 24 to it, and I'm logging a message in the diagnostics log that the max hit is this score. And I'm also setting that to the patch impulse current score, which is feeding into the heads up display. You have to subscribe that function here. So that's the name of my function. This is my patch output. Subscribe to the name of my function here. And then to save the high score, we have this function, which I'm subscribing to the game over pulse. So here is a conditional statement. We are comparing the high score to the current score. So this is my high score variable I declared at the top. I'm just checking if both that and the persistence value is greater than the score. So if your high score is greater than your current score, there's a message that says better luck next time, like, oh, you didn't beat your high score. And I'm sending myself a message in the diagnostics log that the current score was this and the high score is this. So you can see what's going on. If not, that means you beat your high score. So you set the persistence, the user scope, which is that whitelist key high score, to the value of the score. And this is the heads up display message. Instead of better luck next time, you get new high score. Yay. So I have another diagnostics log message just to tell me this is the score I got at the game over, my current score, and that's what the message is, just so I can see what's going on with my script. And this is how you set the string for the time up message to the updated score text. And that's pretty much it for the persistence module. It's kind of advanced for scripting, but I hope I have explained it enough that you can revise it to your needs. I mean, that's kind of how I do scripting a lot of times, is just if you can understand it, you don't have to be able to write it from scratch, but if you can understand it enough of how it works, you can revise it to suit your project. So just to check, if we close out our game, close that game and reopened, tap to place to restart our game. Now we can see we started over. We don't have a high score displaying in that upper left corner of the heads up display, and everything is working as it should. If you're going to test this in your Instagram camera, you're going to want to add your little bunny back into the camera, back onto the camera space position instead of hanging out here in the middle. Here we go. And you can delete this text so it doesn't say false, true, false, false, true, false. I'm going to add the haptic feedback module, which is a new capability just added in version 150 of Metaspark. I tried the script out just on a test project, so we're going to see what it takes to add it to this game. So if you go to the documentation for scripting API, haptic feed modules here, we can copy this script, which is connected to touch gestures. This is the part we're going to have to change for our game to connect it to our script pulse output. So what I'm going to do is just copy that to load the haptics feedback into my score. And I'm going to use this code from the long press function and put that in my score. For when I score a point, I want it to vibrate. And I think we're going to test it out and see if it works. Do we have any errors? No errors. There, hello. So it's working. It's kind of a big thing. So you have to stand up and place the plane tracker on the floor, and you can move your phone around. And when you hit the gems, you get a vibration in your hand, which is kind of cool. It worked. Pretty easy to put the haptic feedback module in. I saw there was somebody on the Metaspark Facebook community page who made a patch for it, if that works better for you. One thing I did notice, the heads-up display shows before you put down the plane tracker and start the game, which maybe I'll change that. Otherwise, wow, I think we're done. I can't believe it. Thank you for coming on this journey with me. Little tweaks. Not only does the heads-up display show too early. Like I don't want it to show until I place the plane tracker and start the game, but also it's left aligned, which we can fix that pretty easy. I just forgot to do something, which I need to find the device. There it is. And divide it, the screen size, by the screen width or screen scale. And then I just need the screen width. Where is it? Where is it? Here. Swizzle. Forgot to swizzle. I only need the width, which is the X value. Otherwise, it was giving me a vector 2. So here, it's centered. Yay! And now that I think about it, I don't want to hide the heads up display. I want to change the start message because, I mean, the whole reason I revised the score script with a persistence module from what Viv did was so that I could show the high score from the very beginning. Otherwise, you could just take Viv's script and use that as is. So I'm going to change the start message to say, welcome to my world. I don't know, whatever you want. See if it fits. Ooh, it's pretty tight on a small phone, but I think, but it scales. That's what this heads-up display is great about, scaling, so I like it. Okay, so I am coming back in here to add a little edit, which I have found there's an issue with this threshold on a World AR experience, whereas there wasn't on the Gem Smash game, because it was a face tracking game. But this, and if you scale the plane tracker, then the distance threshold stays the same. So it's, if you scale the plane tracker down, then your threshold is huge and you don't have to get close to the objects at all to trigger the target. So we need to add the plane tracker scale into this value so that when the plane tracker scales, this distance threshold scales with it. And to do that, we're going to add a little patch input to the manipulation script. So let's go into that. Let's see. Sorry. So I need, first of all, the patches module. Anywhere that the scale, set scalar, the scale, this anchor input, anywhere that is set, I'm going to set my patch input as well. So patch input set scalar, and let's call it tracker scale. You can call it anything you want when you're doing these. And I had it set at 0.25. So this is the initial set active state. So the initial state would be 1 for the plane tracker, and I want my distance threshold to be 0.25. And it's also set, let me just, if you select and hit Command D, it'll show you everywhere that this, every instance of this string. So I should actually, I usually copy and paste everything, but we're going to type it. Set scalar, there is something I'm going to copy. Tracker scale, and I want it to be the same as this instance, which is the new scale. So as you pinch the screen and scale down the tracker, it is going to clamp it from the min scale and the max scale that's declared at the top of this script. So I want that to be the same. But I don't want it to be the same. I want it to be a quarter of that, since I've got it at 0.25. So I'm going to divide, which I believe this is a valid function. It should work. same as multiply. See, like here they're multiplying it to get the percentage. They're multiplying it by 100. So we're using that same sort of method. I just copied my code and I'm going to find the next instance of that, which is here. No, I just went up to the top of the screen. So we have it here, and then we have it here at reset scale function. So I want to do the same thing here. And I don't want it to clamp. I just want to divide it by 4. Save it. This should work. Let's try it out. Okay. No. Oh, I have to do this. I almost forgot. The from script, I need a number called tracker scale. And then, of course, I have to put it here. So let's go back to here and add another resender. Is that the right one? Yeah. Resender, tracker scale, curve scale. Whoops. Go back up here. Receiver, tracker scale, 0.25. Save it. I can add another text to my project just for testing, another testing text. Here, can't see that. There we go. So I can see while I'm testing in the Instagram camera or preview what this value is. I want to make sure this number seems right as I scale down my plane tracker. So let's test that out. So the calculation works correctly. The patch input tracker scale is scaling down. I changed this number to 0.33 just to make it a little bit bigger. And I'm dividing by 3 instead in both instances here. But it's still not quite right. Whenever you scale down the plane tracker, it's like it's not in the right position. So, you know, this maybe is not the best method to do a collision, 3D collision with a world plane tracker effect. If you're really smart, you could do it with dynamic instantiation and do the collision in script as well. There is actually a resource for that. Let's find it. 3D collision Spark AR script. Here he is. Rococo Effie. Ihor Zelenko. Thank you very much. There is a nice tutorial on how to do script collision checking, and I would like to try this out. But we do not have time for this today. So, you know, it works. Don't scale it down. That sucks. That's lame. I could disable scaling because technically you could still reach it, even if it's like huge. You could still reach the targets at 100% scale, even if their world is like huge. But anyway, let's move on for now. So thanks for sticking it out with me and watching me transform the Gem Smash World game into a World AR effect. Hopefully you learned a bit about maybe not so much how to script, but how to incorporate scripts from the API, the Metaspark API, and use it in your project and hopefully customize it to suit your needs. See you.